Hello there, my fellow mathematicians. This is Miss Backfish, and I am making this video for my dual enrollment pre-calculus students. And so I want you to realize we're talking about solving right triangles, but if you are seeing this on the web, you need to realize that I'm going through it a little bit faster because pre-calculus students have seen this before. So if you're seeing this for the first time in geometry, you might need to find a different video to help you out a little bit. All right, so we are in pre-calc. We're solving right triangles. We've already done a lot of this before, so let's just go through it real quick. First off, reminder, right triangles have two legs. They are the sides that meet at the right angle, and they have a hypotenuse. Okay? They have one right angle, and then the other two angles are acute angles. And those two acute angles have to add up to 90 degrees. Now, when we are solving right triangles, what that means is I want you to find every single side length, every single angle. We need to know all 6 of those things. 3 angles plus 3 side lengths is 6 items to know. 6 pieces of knowledge. Now, 2 things that we will use to do that. One is the Pythagorean Theorem sometimes. If you have 2 out of 3 sides, you can use it to find the third side. But one of the main things we're going to use is SOHCAHTOA. One main thing we're going to use is our right triangle trig functions, or our trig functions with respect to the sides of a right triangle. So when we do that, I feel like I've said so several times here. Sorry about that. But when we do that, we are always looking at the triangle from the perspective of one of these 2 acute angles. And we have to know which one we're going to use. And which one we're going to use depends on what we're given and what we need. And sometimes it's a choice. So let's suppose that I need to find this angle. All right. Then I will assign to the sides of the triangle names. This one already has a name. It's the hypotenuse. The other 2, the legs, one of them I'm going to call the opposite side and one of them I'm going to call the adjacent side. Remember that the 2 sides of the angle you're using will always be the hypotenuse and the adjacent. And then whatever's left is the opposite. The opposite side is the one that does not touch the vertex of your angle at all. All right, so keeping that in mind, one other thing I want you to know is that very often when we're working with right triangles, particularly Algebra 2, trig, and beyond, we will name whatever letters for the vertices of the triangle, and then the lowercase version is what we'll call the side across from that. So that would be the length A right here, and this would be length B across from angle B, and this would be length C. We usually write them outside of the triangle, but I already wrote other things there. Another thing is that sometimes we use Greek letters, alpha, beta, for these 2 angles. So just realize that's just like using an X or a Y or an A or a B or anything else to stand for the angles. It's just Greek letters, kind of like using theta. All right, so moving right along, let's go ahead and do a couple of these. It says solve the right triangle shown. All right, we are given that angle A is 28.7 degrees. I already labeled this triangle for you, but if you were just given this information with no picture, the first thing I would do is draw the triangle, label A, B, C, and then put the little b, give the side that they've given is across from angle B, across from the vertex that you've assigned capital B. You would need to be told which angle was the right angle. And usually you are if you're not given a picture. All right, so here's what we've got. That's A, and little b here is 35. So if I need to solve this right triangle, again, it's kind of up to me what I want to use because I've got several things I need to find. I can't use Pythagorean Theorem at all because I only have 1 out of the 3 sides. Pythagorean Theorem only works when you have 2 out of 3. So first thing I might want to do is go ahead and find another side. So how about A? I could find A, I could find C. Totally, user's choice, basically. So let's go with A. If I want to find A, this side is opposite my angle. All right, this side is right next to my angle. Remember that hypotenuse and adjacent, those are the 2 sides that make up your angle. We don't have to call the hypotenuse adjacent, even though it is, because it already has its own special name. So we refer to the other one, not the hypotenuse. that is adjacent to the angle's vertex as the adjacent. So I'm going to have to use the opposite and the adjacent because I need the opposite. It's the side I'm trying to find, and the adjacent is the side I'm given. So that's the tangent in terms of SOHCAHTOA. Tangent is the tangent ratio is the ratio of the opposite side to the adjacent side, and that's how we set it up. I like to think of these equations once they're set up as proportions and cross multiply. 35 times tan of 28.7 gives me, there we go, sorry it kind of appeared there, gives me 19.16. I did want to look at this carefully, and you look at your calculator carefully and make sure you're in degrees, because we are doing a problem that we're given degrees. So tan 28.7 times 35, that is 19.16 equals A times 1. And I always ask my students at this point, after you've cross-multiplied, is the variable alone? If it's not, you're not done. If it is, you're ready. Okay? And sometimes I go ahead and just leave it like this. In other words, 35 times tan of 28.7, and I tell my students, don't bother putting it into the calculator. That's an A, believe it or not. Don't bother putting it in the calculator until the variable is alone, until the thing you're solving for is alone. Okay, so we have this side now. And really from there, I don't have to use another trig function. Very often you only have to use one. I'm saying very often, but I think I mean always. Because now I do have 2 out of 3 sides, so I could use the Pythagorean Theorem. So I'm going to say 19.16, and since it's already my calculator, I'm going to leave it there and square it as is, and be a little bit more accurate than using this rounded version. So this side squared plus 35 squared gives me this number, which is c squared. A squared plus b squared equals c squared. Pythagorean Theorem, leg squared plus leg squared equals hypotenuse squared. So I have the hypotenuse squared right here, and I just need to take the square root of that, and that will tell me the length of the hypotenuse, and it's 39.90. Now I have all 3 sides. 1, 2, 3. I have 2 angles. I'm just missing one angle. Once you know one of the 2 acute angles, remember what we said at the very beginning here, the 2 acute angles of a right triangle always add up to 90. So I can just subtract 90 minus 28.7. And that's going to give me, what, 61.3? 61.3 degrees. So now I've got everything. I've got 1 side, 2 sides, 3 sides, 1 angle, 2 angles, 3 angles. I know all that I need to know for this right triangle, which means that the right triangle is solved. That's what it means to solve a right triangle. All right, let's try another one. I'm going to see if I can zoom out a little bit more first, though, so that I can fit more in the screen. Okay, here we go. Here we've got another one. It's a right triangle. We're asked to solve it. We're given the measure of angle B, and we're given the length of side C, which is the hypotenuse. I would suggest pausing your video here, try it yourself, and then come back and join us and see if you are on track. All right, so B is 38.2. I'm going to label my picture. And C is 42. And then I'm going to go ahead and label what the sides are in relation to this angle. So in relation to this angle, this is my hypotenuse. That's actually not really in relation. This is the adjacent. And that makes B the opposite. Okay, now we ended this the last problem this way, but if we want to, we can start this one this way. I can go ahead and find the third angle right now because I know one of the acute angles. So I can do that. I could go 90 minus 38.2, and that gives me, what, 51.8, I think? All right. So now I've got both angles. So now my options are even a little bit wider because I could use almost anything to find the missing stuff. I could find A first, or I could find B first. That's a choice I have. I can choose whether to use sine, cosine, or tangent, depending on what I want to do. I think I'm going to go ahead and find A first, just to be alphabetical. And I think I'm going to use this angle to do it. And if that's the case, then I'm using the adjacent over the hypotenuse. Now, let me point out, I could use this angle now. But remember that when I labeled opposite and adjacent, I was doing that with respect to this angle. So if I'm going to use this angle, if I'm going to use the 51.8 degrees, this would be the adjacent side, and this would be the opposite. Whatever's opposite of one of the acute angles is the adjacent for the other, and vice versa. So we're going to use angle B. We're going to look for side A, the side labeled A really, and we're going to use the other side that we have. That's the only side we can't use. So adjacent and hypotenuse, that's cosine. So the cosine of 38.2 is equal to the adjacent over the hypotenuse. Now I'm ready to cross multiply. I get 42 times cosine 38.2. And is A alone? Yes. That means it's time to pull out the calculator. I say this because that's a common mistake a lot of students make, is they try to start putting things in the calculator before they know what they need to put in there, or before they've done the legwork to make sure they're accurate in terms of, am I dividing, am I multiplying, what do I need to do to find my missing value? And here I get 33.01 if we're rounding to the nearest hundredth. So A is about 33.01. Okay. Now, in the last problem, I used the Pythagorean theorem next because now I have two sides. Absolutely possible to do that, and then you only have to use a trig function once. But if you want, you also could go ahead and just use a trig function to find B. Some people prefer to do that, and that's absolutely fine. So I could either use angle B and now use opposite and hypotenuse and make it the sine, or I could use this angle and make it adjacent and hypotenuse and make it the cosine. Let me caution you about one thing. If you choose to find, well, and this kind of doesn't, it applies and it doesn't apply. One of the values of doing a new trig function for B is that if I use A to find B, A is really this. And really it goes beyond that. That's only as much as my calculator can show. This is a rounded version of A. This is a decimal approximation of A. So really, if I'm using a number that has been rounded or is an approximation to find another value, it's kind of like I'm starting out at a disadvantage. I can't be as accurate as I might want to be because I'm starting out with something that's not quite fully accurate, so to speak. So that's a disadvantage to using the Pythagorean theorem, and that's something that I would not want to do if I were to use a trig function. Like if I said, I'm going to use tan with this angle up here, and I'm going to say opposite over adjacent. I wouldn't do that. If I were using a trig function, I would go back and use C again. So let's do that. Let's use, why not go ahead and go with angle B and say the sine of angle B, opposite over hypotenuse, is opposite B over hypotenuse. All right, and then we've got 42 times sine of 38.2. Now, am I talking about a huge difference when I say you're using a less accurate thing to find your final answer, and so it's, you know, starting at sort of a disadvantage? I'm not talking about a huge difference, and it may be negligible. In a lot of cases, it will be, meaning not big enough a difference to really matter. Let's see. But let me just show you what I mean. Okay, this is what I found for side B. There's side A. Let's suppose I had done the Pythagorean theorem. That would be A squared plus B squared equals C squared. So C squared, which is 42 squared, minus this squared, 33.01 A squared, should give me B squared. And then when I take the square root of that, this is what I get. It's not exactly the same. But you know what? Rounding to the hundredth, you know, it becomes the same. So again, it's not a huge difference, but in general, it's kind of a better plan not to use a number that has been rounded to do the next step of a problem, if you have a choice, if you have another way of doing it. All right, let's go with another one here. This time, we're being given 2 of the sides, none of the acute angles. Okay, so we have A is 13.5, B is 22.4. I'm ready to go with the Pythagorean Theorem, really. I've got leg squared plus leg squared equals hypotenuse squared, so let's do it. And remember, there's a lot of approaches here. So if you see something, if you look at it and you're like, oh, the first thing I want to do is this, why'd you do that? Totally your choice. You can do things in a completely different order than me and still be absolutely 100% perfect. So this is, C is 26.15. Now I've got all 3 sides. So that's nice. And a cat hair. All 3 sides I've got. Now I've got to find an angle. Since I've got all 3 sides, I really could use anything I want to find the angles. But I just found this, and that was me finding it and rounding, so I probably wouldn't use this. I would probably stick with the 2 pieces of info I was given. Because this is approximate, but we can assume that they're giving me accurate. A is exactly 13.5, etc. Okay, so let's find A first. So I'm going to, well, I was going to call it X, but there's no reason to. It's already got a letter. So let's say I want to find the measure of angle A. All right, if I'm using these 2 sides, this is opposite from A, this is adjacent to A. So I'm using tan. The tangent of A is opposite over adjacent. Now, this is the only time we use, on the calculator, our inverse. The little bitty above each of the sine, cosine, and tangent, we've got a little sine with a -1, cosine -1, tan with a -1. This is basically working backwards. I'm saying the tangent of some angle is equal to this. So if I want to find the sum angle, I have to work backwards. I say, what angle gives you a tangent? So inverse tan, what angle would give me a tangent of 13.5 divided by 22.4? And that's 31.076, so 31.08. So I would say A, and let me just go ahead and write out the work we just did. So the measure of angle A is about 31.08. And again, once you have one of the 2 acute angles, there's no need to do a lot of jumping through hoops to find the other one. We can just subtract from 90. 90 minus that answer gives me 58.92. And now I have all 3 angles. I have all 3 sides. The triangle is solved. Now, a couple of more problems I want to show you just because, oh, hang on, my dog wants to go out. Okay, I am back, and I was saying sometimes you get problems that are a little bit more of an application problem or a little bit more of a combo, or there's a twist, or they want you to put together this knowledge with something else, and here's one like that. Okay, it says find the length of X. All right, I've got 2 right triangles. When I kind of analyze this, I see that I need to find this length in the top triangle, and then I need to find this length in the bottom triangle, and then I can add those 2 and get X. So I am in the top triangle given an angle. I'm looking for the opposite side, and I'm given the adjacent side. So I can say that the tan of 36 is equal to, I'm going to call this X sub 1, is equal to the side that I need here, this little piece of X, over 425. And when I cross multiply that, I get that expression. Okay, and so I know that when I put that in my calculator, I'll have this little part I'm calling X sub 1. And then for the bottom triangle, this is again my opposite side. This is the adjacent side. This is the right angle. Let's call it X sub 2. So the tan of 22 this time equals x sub 2 over 425. Same scenario, 425 times tan 22 is going to give me my x sub 2. So if I need all of x, I need to add x sub 1 and x sub 2. And that would be 425. Let me type it in first so you can still see that. 425 tan 36. You see my cat's paws jumping across there. Plus 425 tan 22. And I tend to be a little paranoid about letting the calculator do the order of operations, so I always make sure I give it the extra information that this is all together, even though multiplication does come before addition, so hopefully the calculator would know. And the calculator has given me 73,286. That just feels wrong, doesn't it? I don't know. Let me do it separately, just to make sure that I'm not right in not trusting the calculator there. Or maybe that when I say I was careful, maybe I wasn't so careful. Maybe I typed it in extremely poorly. Yeah, 308 for this guy. So yeah, that's pretty far off. Plus 425 times tan 22. Yep, my total final answer should be 480.49. That seems a lot more reasonable, doesn't it? 480 point, what was it, 49? Yeah. Okay. Now, let me just point out that when I have told you to do this with cross multiplying and then saying, is this alone? And I'm just going to keep talking, although the dog's barking. I don't think you can hear him that well, hopefully. Although she's trying to get louder. The reason for that is that sometimes at that point, your variable's not alone. Like, for instance, let's say I've got this scenario, okay, and I'm supposed to be finding x. Well, this is opposite from the angle that I'm working with, and this is hypotenuse, so I'm going to use sine. And when I set that up, my variable is in the denominator. When my variable's in the denominator, when I cross multiply, I get this. X is not alone. Okay, so my point is, unless you have the variable alone, you're not ready to put things in the calculator. It's only once you have x alone that basically the equation is now set up to tell you what goes in the calculator. So now it's telling me x is alone. To find x, this is what you're going to do. So it's not always multiplying. I just happen to, unfortunately, pick examples that have all been. Sometimes we will be dividing. And a common question for students to ask is, how do you know when? Well, this is how you know. You don't just randomly divide or multiply at the beginning. You set up the equation, you solve the equation using what we know about solving equations in terms of cross-multiplying or multiplying to get something out of the denominator. And you solve, meaning isolate the variable. And when the variable is isolated, you say, okay, whatever's on the other side is what goes in my calculator. If it tells me to multiply, I multiply. If it tells me to divide, I divide. Okay, for our grand finale, we're going to do an angle of elevation or angle of depression problem, because this is one of the most common types of application problems that we have. Actually, I said grand finale, but I got two more. Sorry about that. Angle of elevation, angle of depression basically means this. From the horizontal, are we looking up or looking down? If you're looking up above the horizontal, if your angle has one side that is horizontal, which it has to have, and the other side is above the horizontal, that's an angle of elevation. If you have an angle and one side is horizontal and your other side is below the horizontal, that's depression. One side has to be horizontal. Now, why am I emphasizing that? Because very often you have a scenario like this. Somebody's looking down at a car on the street, blah, 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 I don't know, this number's given, This number's given, or what? Well, that might not be given. Let's say it's not given. And you're told that the angle of depression from the person to the car, which I did not draw, and I know you want to see my fabulous car drawing skills, is 30 degrees, or what have you, whatever degrees it is. People want to put that right here. But look at that angle right there. One side is vertical, one side is not anything. Well, it's neither vertical nor horizontal. That cannot be an angle of elevation or an angle. So what does that mean? If you tell me the angle of depression from this guy, I think, okay, going horizontally out from this guy, here is my angle of depression. Okay? There is my angle of depression. Well, but that's not in my triangle. What am I going to do? Sure it is. Remember alternate interior angles? Do you see it? This angle is the same as this angle. Okay, so remember that if you're looking and you think you've identified the angle of elevation or depression, it has to have a side that's horizontal. If it doesn't, then you need to look again. Okay, so if the angle of elevation of a sailboat to a top of a cliff on shore is 38.2 degrees. So I've got the sea, cliff on shore. Let's say there's a little beach, there's the cliff, and this is my sailboat. The angle of elevation to the top of a sailboat to the top of the cliff. So in other words, we're looking from the sailboat to the top of the cliff. This is called the line of sight, and very often that's what your sort of diagonal looking line is the line of sight. So from the horizontal, this is what we're talking about. This is my angle of elevation. This is 38.2 degrees. How far is the ship from the base of the cliff? So that's this distance. How far is the ship from the base of the cliff, if we know the cliff is 70 feet tall? So I kind of crammed all that in a little space, but that is what they're telling me and what they're asking me. So I'm going to say, well, for this angle, that would be the opposite side. And for this angle, that is the adjacent side. The x is the adjacent side, so I'm going to use tan. So tan of 38.2 is equal to 70 over x. Cross multiply. And is x alone? No, so I'm not done. Got to get x alone. So I divide both sides by tan 38.2. Now x is alone, and that's what tells me what to put in the calculator to get the value of x. So 70 divided by tan 38.2 tells me that x is going to be 88.95, what is it, feet. That's how far away the sailboat is from the base of the cliff. Last one. Romeo is walking toward his Juliet on her balcony. The first time he checks, the angle of elevation to her is 42 degrees. So he stops, he looks up, the angle of elevation to her up on her balcony. Balcony, Juliet, walking to her. He stops, looks up, angle of elevation is 42 degrees. All right. After that, he walks 20 feet closer, then finds the new angle of elevation is 56 degrees. Okay, so he keeps walking toward her. Now he's here. New elevation, angle of elevation, excuse me, is 56 degrees. And we said he's 20 feet closer at that point. So we know that this distance is 20 feet. We still don't know how far he is from the bottom of the wall on which her balcony is. We still don't know how high the balcony is. We don't know this distance. This is all we've got. So what are we going to do with it? Well, sometimes, very frequently actually, when you have a problem like this and you're like, I don't know how to find that, well, figure out what you do know how to find. What can you find? First of all, let's label H what we need. All right. And then I'm going to go ahead and I'm going to call this something. I need to call it something. I'm going to call it x. Excuse me. So what I've got there is I've got two triangles, really. The first triangle with the 42, this distance is 20 plus x. Okay. The second triangle for the 56 degrees, this distance is just x. All right, so I got two different triangles. There's my scenario. What can I do? Here's the key. It's the same h both times. So if I can set up an equation about this h and an equation about this h, I can set them equal to each other because it's the same h. Her height doesn't change between scenario 1 and scenario 2. So if I look at this and say, okay, tan of 42 is h over 20 plus x, which means that h is tan 42 times 20 plus x. And over here, tan of 56 is h over x, which means that x times tan of 56 equals h. They both equal h, which means they must equal one another. Transitive property, remember? So, and I'm sorry that I wrote the x on one side over here and on another side over here. It really doesn't matter. I'm going to go ahead and say, let's distribute that as we rewrite our equation. What equation? The one that says this has to be equal to this because they're both equal to h. So 20 times tan 42 plus x times tan 42 has to be equal to x times tan 56. Now, you could, I was going to say cheat. It's not cheating. You could go ahead and get a decimal approximation for tan 42, a decimal approximation for tan 56, and probably make this a little easier on yourself. If you want to do that, great. I'm just trying to be as accurate as possible and leave that all till the end. You don't have to, because it's probably not going to be terribly inaccurate if you were to round that, as long as you didn't round it to too much. Sorry. This is tan 42. I'm losing track of what I'm doing. So 20 times tan 42, I should have written that a little lower, is equal to x tan 56 minus x tan 42. What am I going to do? I've got x in both expressions. I'm going to factor it out. 20 tan 42. This is why you learn all the algebra before you get to pre-calc. Tan 56 minus tan 42. I'm finally almost there. Now I am almost ready to say that x is by itself, and I can stick it in the calculator and set. Boom. X is by itself. If I put that whole mess in the calculator very carefully, still not sure what exactly I did wrong earlier, but I didn't really go back and look either. So 20 times tan 42, and I'm going to press enter to make that all one number, divided by parentheses tan 56, close parentheses, minus tan 42, close your parentheses again, 30.9. What were my units? Feet. 30.9, and I said 30.9, but it's 30.93. 30.93 feet. Voila! I hope this has helped, and I will see you next time.